Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Everyone, and welcome to the talk. It's my pleasure to introduce James Noble, who has done work in many different areas of computer science and has wide interest in software engineering related things and programming methodology related things, and you may know him from the work that he's done on ownership types, for example. And he's going to tell us today about patterns.
Great. Thanks, Rustin. In fact, I'm not actually going to tell you that much about patterns, which is a good thing with Ward sitting in the room, I always think. I must admit, in talking about this, I was a little bit nervous, but then, as you'll see, one definition when I'm either having a bad day or a good day, I'm not sure if I can decide which, is quite a lot of my research in the last few years has been trying to theorize and academicize stuff that Ward's been involved in for long before I ever got involved. So this talk, in some sense, is an example of that. It's work that I did in conjunction with colleagues, originally all at Victoria, but now Robert Biddle is on an extended sabbatical come stay at Carleton, and Ewan Tempero has moved to the University of Auckland in New Zealand. And it's called Patterns as Signs because this is an attempt to connect particularly the kind of computer science side of patterns that people like, well, Ward and the gang of 4 designs people who've been doing software, and trying to connect that to, if you like, a liberal arts or a literary understanding of the kind of structures people use as communicate. In particular, the structures here I'm going to be talking about are these things called signs, which, well, they're basically just signs. Like, you know, the one on the back wall, and the theory of that. And technically, this is the Charles Peirce extended remix dub version of the talk. Various was given at eCoop a few years ago and various other places, and this is sort of the next one along. So what have I done? In my old small way with Charles Weir, I worked on design patterns. We have a book there for design patterns, and at this point I realized I'd left my mobile phone in the bag somewhere. Design programs for systems with small memory, things like mobile phones and PDAs. These days I noticed the running example, which at the time was a joke, was a watch-based PDA. But I saw on the Hammer Schlemmer catalog, as I was flying up on United, that in fact people are now selling watches that are running Palmos. I presume there must be watches running Windows CE. Running .NET? Yeah, but are they Skynet catalog yet? That's what I want to know. That's clearly one definition of the success of any technology, that you can buy it sitting in the back of a plane. I've done work on software visualization. In fact, this is an interesting project. This is actually one of the first visualizations we did of a visual language. And one of my other interests I share with Rustin, and no doubt others of you, is programming. That's a little synthesizer called the Nord Modular, which is a synthesizer, a digital recreation of an analog synthesizer. And so this is actually a visualization of one of the control units, or one of the control programs for that synthesizer. And it's using color coding in a couple of ways. The interesting thing you can see is that, you know, these gray bits are the oscillators. They're always, it turns out, you know, you can see particularly the oscillator. If I showed you the original program for the synthesizer, all of those boxes would just be boring gray colors. We've color-coded them here to show the type of oscillator they are. And this view here shows, kind of think of it as about 1,000 of these being superimposed. Okay, so what this says is, most of the time when you read one of these programs, the oscillators are going to be in the top left-hand corner. Okay, the red bit, which is just sitting down there, they tend to be on the bottom right-hand corner. They're the outputs. Okay, so this is obviously a software visualization. I'm talking a bit about it because a theme coming through this talk is the way in which In this case, we can use signs, in this case, graphical displays like this, to understand the patterns that you might find in a program. If you have to understand one of these control programs, literally you don't know where to start. The way the synthesizer works is each of these blocks can be put anywhere on the screen. What this visualization is telling you is the green, oh, that's the input, pretty much at the top left. Underneath it and possibly beside it are all the oscillators, and then signal flows through a range of signal processing modules, and the output is on the bottom right. Okay? So in this case, we actually did a little bit of experimental analysis of the programs to see how these kind of programs worked, and in this case, we were able to visualize them like that. This is another one of the areas of research. Ruston mentioned ownership types. Ward said he was working on web services security. This is actually a picture of us, some work we did a couple of years ago with David Clark and Mike Richmond, other students of mine, one now in Amsterdam and one at El Marden down in California, using ownership types or a system based on ownership types to protect Java's EJB web services. The issue here is in the EJB web service, there's a particular component here that has got some kind of objects, and its implementation depends on these objects being kept inside the EJB component. If you ever get a reference from some intruder outside into one of these components, then they can wreck the integrity of the system, can update the database, bypassing any security checks, all these other kind of bad things. And we have a type system that can actually be used, effectively a type system that can be used to give guarantees that those kind of things can't happen in your web service. And finally, the last slide, click to add title, is work that I've been doing on, if you like, the philosophical basis of a lot of what I think is happening in computer science, the shift from a modernist idea to a postmodernist idea. I don't want to talk about this today because whenever I talk about this, I think 2 or 3 of you would love it, and the rest of you would just decided that you hate me. So I particularly won't do anything that says that, oh, that Ward Cunningham stuff, it's this postmodern. I will say, if you want to know how, for example, this VW new Beetle and the new Macintoshes and, I don't know, something like .NET CLR are all related, then you can come and talk to me afterwards. So what I'm talking about today, though, is this issue of, in some sense, what are design patterns? How can we think about them? And in particular, this issue of how can we use what's basically 100 years of tradition from the liberal arts side to understand what design patterns are and how they work. So I'm going to start by talking about some basics on this idea of semiotics, which is the study of signs in society, and then go on and show how that relates to patterns. So semiotics, such as it is this branch of, well, in some cases a branch of linguistics that's about 100 years old, founded by, in Europe by Ferdinand de Saussure, who actually called it semiology, and in America by a famous drunkard and adulterer, Charles Sanders Peirce, who often is considered the US's leading philosopher. Both of these people had this idea that reasoning, at least as done by humans, is not done directly with reasoning with concepts that in some sense stand for themselves, but by reasoning with this idea of signs, something that stands for something else. So the French at this point get involved in the 1960s. Roland Barthes, his interesting book Mythologies, we'll actually use some of that later in the talk. And then, of course, the famous Derrida post-structuralist kind of philosopher that everyone seems to get worried about these days. But in fact, my favorite recent semiotician is actually Umberto Eco, who, once again, semiolinguistics is often working at this boundary between linguistics and semiotics, and we aren't allowed to be too scared by him, because, of course, he's also a famous novelist who wrote The Name of the Rose, which, once you've read semiotics, in some ways gets a lot more interesting, or at least once you've read eco-semiotics, Because a lot of what that novel is about, in fact, is precisely this issue of relationships between signs and between the things they stand for and about how they work in sign systems. The library at the end of the book is, and in fact the entire monastery is constructed as this complicated analog of the way society works. And I mean, you find it in the title of the book. The name of the rose is raising precisely these kind of questions. And a lot of the semiotics I use here basically come, at least my first approach to it, was from Eco's treatment of it. So what is it? Well, really the idea of a sign is pretty simple. Whether it's the kind of signs on top of the screen or the one at the back of the room or the sign I've got here or the sign I've got here on the Lord of the Rings t-shirt I'm very proud to be wearing. A friend of mine was on the film. It's something that stands for something else. That's all it is to it. In Latin, aliquid stat pro aliquo. So the idea is we might have something that Saussure would call a signifier, cattle crossing. Okay? It's a sign on the side of the road. It's going to refer to something. We'll call that the referent. Now, the whole point of the sign, though, is that it refers to something in the absence of the thing to which it refers. Okay? There's not a lot of point having a cattle crossing sign if in fact there is a cow standing in the middle of the road. You can just see the cow. The point of the cattle crossing sign is to say, look, cows might be crossing here. You're not going to see the cow. You are going to see the sign. And then in the tertiary model of semiotics, we then say we have a signified or interpreter or an idea which is formed in the mind of a person interpreting the sign which says, watch out for cows. Okay? So this is the basic model of the sign that I'll be using in the talk. So the thing about signs is that all of these things can be different. So we can have a different signifier, picture of a cow. We can have exactly the same referent. We get a signified, still watch out for cows. But this is a different sign. What we've changed is the signifier, but the rest of it remains the same. Okay? And so this articulation, this duality here between the words or the signs or the signifiers that we use to represent things and, if you like, the content or the idea or the signified that we are using the sign to represent. And semiotics is about managing the difference between these kind of things. The same sign, I originally, I think, gave this talk at ECOOP in Spain, could represent a bullfight, and you'd think, okay, that's the Plaza del Toros. The same sign used to refer to me giving a talk, and you might decide that, well, the talk's content-free. Or rather, the same signifier, because all of these are different signs. In fact, this idea of difference is an important part of semiotics, because particularly in Saussure and sort of the European structuralist school, the idea is that these things don't have an absolute value. Okay? So both signifiers and signifiers are defined by difference. So the point is, it's not that, whichever one of these rather nice graphical icons, it's not that, this icon has to be 1, 2, 3, some number of pixels long, and this has got to be some number of pixels long, and the color shades have got to be right. That's not the way this works. The way this works is we have a system here, and the difference here are between whether these ends are flush and these ends are ragged. So 2 ragged ends, 1 ragged end, 2 flush ends. Okay? The argument is that this is the way both signifiers are separated from each other and also the way meaning is constructed. Okay. In English, the pronunciation between the words read and rid and read, that's not a constant amongst all speakers of English. Many people here will probably pronounce those words differently to me. But the way we can understand what each of us is saying is because the actual meaning is generated by this structure of differences. In the same way in other languages, I think in French, there's the word forêt and the word bois, meaning forest and wood. There are various other words for this as well. The point is the differences where those concepts lie are not in the same places as English. So something that, an Englishman might consider a forest, the French would consider a wood, and so on and so forth. And you find this kind of thing happening all the time. The point is that there isn't any absolute definition for all these kind of things, or for most of the things we talk about, unless we're using a particular formal mathematical language. Rather, we've got these concepts that kind of push against each other. And the meaning comes by the structure of differences, and we'll see that turns out to be important. Finally, this is probably the stuff that if people have come across, for example, use of semiotics in interface design, where things are most common, the idea that considering the signifier and the referent, we can categorize signs into particular types. So the first type of sign is an iconic sign, and probably Apple's use of the word icon in user interfaces actually comes from, this is actually Peirce's term, iconic. Iconic sign is one that works by likeness metaphor. A picture of a cow is an icon for a cow. This is an iconic sign because, well, it looks like a right justified paragraph. Okay. Indexical signs are signs related by cause, effect, or subpart. So a box of milk for a cow, that's an indexical sign because the milk is produced by the cow. A picture of a cow's head used to represent an entire cow is similarly an indexical sign because we're representing the whole cow simply by a picture of part of it.
The yellow sign is indexical too then, because it only shows one side of the cow.
Yeah, well, you know, if you want. I will take abuse and questions throughout this talk, by the way. I should mention that. If you're upset, feel free to wade in. Feel free to, hopefully I'll get more comments than I do from many of the students, you know. Symbolic signs, or any other questions on the stuff so far? Symbolic signs are arbitrary conventions, okay? Cattle crossing, well, you know, if this was in French or Maori or something different, the words would be different. It's an arbitrary convention. You wouldn't understand what it was. The important thing about signs, says Umberto Eco, is that they can lie. So the whole point about this is we're making this articulation, this distinction between the signifier, the thing we see, the referent, what it stands for. We've said it stands for the signifier stands for the referent, but in the absence of the referent. And so if you can tell a lie, says Eco, then you have a sign. And if you can't tell a lie, then you don't. So painting, you know, when you're the rich aristocrat or whatever in Europe in the Middle Ages and you hire a painter in to paint your portrait, and he paints your portrait with you looking much more opulent and much more healthy than you actually were in life, which is why when you do wander around the portrait galleries, you think, gee, those kings and queens were rich, happy people. No, they weren't rich, happy people. They just had, you know, good painters. These days, advertising, you know, when you're in that Hammer Schlemmer catalog, you look at the picture of the watch running Parmos and you think, gee, I really, really want that. It's great. Eco says, but mirrors aren't signs in this respect because, you know, they give back precisely what you put in. A flat mirror isn't a sign because a mirror doesn't have that capacity to lie. And so the point is there are, in fact, a range of lies. You know, you can have signs that don't have a reference. You can put up signs that say cattle crossing, well, when there aren't any cattle crossing. You could just have the wrong signifier. You could have cattle crossing when, in fact, as happens in Wellington, it's actually penguins that cross the road in various places. This can be unintentional or intentional, and these kind of misinterpretations can be driven by the reader or the person understanding the sign or the person creating the sign. The nice thing about this idea of signs is it has built into it this notion that what we go on, what we communicate, may well be misinterpreted. And related to that, the idea that ultimately meaning is built up by some kind of process of negotiation, which is why it is good that I do stop every so often and ask the questions, and why if you've got questions, you can ask me, and I'll change what I'm speaking based upon those kind of questions. Built into the notion, the semiotic notion of communication, is this whole issue of lies, misinterpretation, negotiation. So semiosis then is Peirce's term for the process of interpretation of signs. And he says, look, there are three kinds of logical reasoning. The first is deduction, which is the kind of logical reasoning, well, you probably think of when someone says, well, logical reasoning. So the idea here is you have some kind of rule, like there's an urn full of black marbles. You have a case of the rule, you've taken a marble out of the urn, and you deduce a result to say this marble is going to be black. Inductive reasoning, and in general, this says, okay, well, what have we got? We've got a black marble, and we know in this case that the marble came out of the urn, and if I was being mathematical induction, I'd have to add the proper inductive case, which says the marbles in the urn are the same color, and we can therefore conclude that all the marbles in the urn are black. But Peirce says the third kind of reasoning is what happens when we interpret signs. It's the kind of reasoning that Sherlock Holmes uses all the time. He calls it deduction, but what he's doing is abduction. We have a result. We've got a black marble. We imagine somewhere there is this urn containing the black marbles, and what we're interested in doing is saying that marble came out of the urn. Okay? This is what Sherlock Holmes does when he finds the cigarette. He looks at the result of the cigarette and due to his extensive knowledge, works out that, you know, this is a Turkish cigarette and can see a little bit of lipstick on the end of the cigarette and hypothesizes that some rich Turkish aristocrat was standing outside the window at which the unfortunate Mr. Jenkins was shot, or whatever it was. But this is what we do in programming. What we find is some result. Okay, what we find is some result. We find some bug in our programs, or we find some bit of source code that we're looking at that we don't understand. And what we do is we form a theory, we hypothesize some kind of rule. The program is broken in this particular way, a rule that will let us generate a case that will give us the result that we see. Okay? So my argument is that this kind of reasoning, which is the kind of reasoning that is implicit in this model of semiotics, is the kind of thing that as computer scientists we do all the time. As software engineers, this is what we actually do. Even if we're much happier telling ourselves this story that what we're doing is deduction, that we start from the formal specification and we work all the way down to the code. I think that a lot of the time what we actually do in computer science is right here on the other side of the screen. So what's this got to do with OO and design patterns? Well, let's think about the classic story we tell ourselves for doing OO. Being a New Zealander, I'll say we've got a farm, and you know, I believe that these are actually the technically correct UML models for the particular animals we've got in our farm. Although someone did say if you use UML graphical stereotypes, you could in fact draw your model like that. Stereotypes are great. You know. If I was being really mean, I'd say, and Visual Studio's domain-specific languages is going to let you do this too. It's pretty cool, I think. You know, much. What would you pick?
Farmers love it.
Farmers will love it. Yep. And they buy a lot of computers. Thank you, Seymour, wherever you are. So the question is, how do object-oriented programs model real world? Well, this is the story that the Scandinavians tell, and they should know because, in spite of what Alan Kay says, they invented it. A program execution is regarded as a physical model simulating the behavior of a real or imaginary part of the world. And if I was teaching a class, I would read it twice. And then I would ask, well, fine, but what does it mean? What does that mean? Well, you know, wearing my modernist hat again, I'd say it's heroic. You know, out there, through that window, is the world. We are programmers. We are going to invent the future. We are going to go out to the world, and we are going to model it in our computers. Ah! I feel good about that. Thank you. Except, of course, it's not that simple. Sometimes we create the world as we model it. I have to have in my job these depressing conversations with people that go things like, are they an RX or a DP or a WP? Meaning, is the student enrolled, or have they signed up but not paid, or are they only waitlisted? Well, where did this idea of waitlisted or enrolled or unenrolled come from? Where did that idea come from? I'll tell you, it came from somebody modeling the world and building a computer system. Okay? The kind of things we build in our computer system really matters. As one of Ward's things that I love quoting, our computer systems change the world, you know? reading something on slate.com this morning, about receptionists in this building. They said it really matters, apparently. You can tell me if I'm right. The kind of categories, the codes that you have on your badge at Microsoft. Where did those categories come from? At some level, they came from people like you or like me sitting in a room and doing something that they thought was object-oriented modeling or some kind of computer system modeling. Meaning comes from difference. The differences that we create when we build these kind of models end up structuring the world that we think of as existing externally to our systems. And those differences really do exist. What's more, there are a whole lot of things that cannot be modeled in the computer system. My favorite example of this is the untraced stolen library book. A typical example we use in our O design class is, well, you're modeling a library. It's a fairly standard thing. Well, then the question is, how do you model a missing library book? An untraced missing library book. Well, gee, you can have a flag in your thing that says missing, which means we bought the book, we know it was there once, but now it's missing. Okay, but we want to model a book that's missing that nobody knows is missing yet. Because it's actually really, really irritating to go to the catalog and see the book's there, and you go to the shelf and you try and find it and it's not there, and you go back to the librarians and they say, I'm sorry, that must be an untraced missing book. Tell you what, I'll turn on the missing field in the database. Well, how do you model that in a computer system? Well, by definition, of course, a book that's untraced and missing is a book that isn't recorded in the computer system as being missing. That's great, that's helpful. Even better, there's this question of, is the world made of objects? We want to model this room, so we will have an object representing the chair, and we will have an object representing the table. Yeah? And we all know about objects, and so they're encapsulated. So this chair is encapsulated. And this is clearly the case because if I got a knife and threatened to break the encapsulation, at least the facilities people would start to get upset. And I suppose I could say, what about polymorphism? Well, there's the sit method on the chair and the sit method on the table. And this works by interfacing, with the polymorphic, .NET interface defines, or alternatively the decom vtable pointers of the chair and the table. All right? What about sunshine? Is that an object, like a chair? What about my credit rating I've discussed here? Credit rating's one of these things. It's real. If my credit rating, someone hacks my identity and my credit rating goes down the tubes, I'll have difficulty getting on the plane back to New Zealand because when I try and log in using my credit card to authenticate at the United automatic check-in system, it will say, thank you very much, Mr. Noble, I'm confiscating your credit card. What about gravity? Well, let's consider the stack. Good computer scientists, good object orientation, we all consider the stack. Well, we know from Dijkstra 101, the stack is an abstraction of some concrete implementation. A stack is a specification that implementation fulfills. And I'm sure that .NET and Java and various other languages have a stack implementation you can get by doing the appropriate import in your code. It elides or ignores details, and in fact, this is there's an explicit mathematical definition based on the lambda calculus to say what this means. We encapsulate behind an interface. So we have this interface, and we have this other code, and we do a lambda abstraction to get rid of all the code and make the names we want visible in the outside context. All fine, yeah? Cool. Apart from the bit in Alan Kay in his history of object orientation when he says, stacks aren't an object. Okay. Well, let's try bovine. Is this a data abstraction? Do we mean to say, like many of our textbooks on object orientation do, an object, a class, is an abstraction of something in the real world? So the bovine class abstracts the real cow in just the same way up here. So we have a lambda function with the real cow in it at one side and this thing in the computer system on the other. And presumably our bovine class must be implemented by the cow if it's going to work in the same way that the stack does. Okay, maybe that's wrong. Maybe, in fact, we could look at Plato and say, I'm making a confusion here between the bovine class and object instances of that class. And so like Plato, in fact, what's going on is the bovine class is some kind of concretization, reification of Plato's ideal, perfect, immutable form of a cow, which is also something I don't really think is particularly tenable. Given the topic of the talk, what I'm going to say is a way to think about this is that these things are signs. Got the idea of our signifier, referent, and the interpretant, meaning watch out for cows. So the key idea of this talk is, well, an object can be a sign. So what's going on from this perspective, under this doctrine, as Eco would say, is we're going to take an object not as an abstraction, but as a signifier. And the cow is the referent, the thing that this particular object is referring to. And then we make an interpretant, a signified, which says this object, for some purpose, is going to represent or is going to model this cow. Okay? It's not a relationship of abstraction. It's a relationship of signification. So this is my current take on what object-oriented modeling, and in general, all kinds of modeling in computer science means. Yeah?
How does this relate to the idea of views? So that, you know, something you simply call cow, I might think of one moment as being a lawnmower and the next minute as being a fertilization factory. You know, I could take multiple points of view on the same cow and think of it for, you know, in multiple ways depending on my usage. It seems like signs is kind of heading in that direction as well.
Yes,
right?
yes, you're right. That's a good question. And being able to have that built into, if you like, the ontology that I'm using to think about these things is a motivation for doing things this way. Because what you're saying there is we can construct a bunch of different signs that have the same referent. Mm-hmm. They're going to have different interpretants. They're going to have different signifiers. So just in the same way as you can have different cattle crossing signs, same referring to the same cow, whatever.
What about the cases where your object doesn't have any referent in the real world?
That's absolutely fine. Once again, in semiotics, nothing says that that referent has to exist in the real world. So, you know, dragons are fine.
But I don't even mean the sort of phenomenological case. I mean in the case where there really is, where you're not modeling something. So if you're creating some kind of computer model where the only things that you're talking about are the stuff in the actual model itself.
That's also fine. In that case, if, for example, you are doing some kind of program analysis, mm-hmm. then you'd probably say, yes, well, I'm at some level doing meta-programming. Mm-hmm. Okay? So semiotics, particularly this is where Roland Barthes comes in, talks quite a lot about metalinguistic systems. Did it before we did it in programming and basically says, this referent is another sign, another part of the linguistic system. Okay?
So it's turtles all the way down?
Pretty much. I can start talking about Peirce's unlimited semiosis in the indefinite interpretant, but I won't, partly because I don't really understand all that stuff. But that's right, yeah. In that case, that's what you do. And if there is no referent, well, that's fine, there is no referent. And for those of you who like, anyone here does read Umberto Eco's novels? Okay, good. Any of you make the mistake of buying Kant and the Platypus?
Oh God, yes.
Which was on the airport bookshelves, which is
where I bought it.
Right, which is extremely detailed treatise on important points of semiotics, of which the first chapter is being and nothingness, or on being, which is a relationship with Kant, thus the Kant. Kant's essay on nothingness, which is precisely this issue of can something exist if it doesn't exist, precisely your point. So you could borrow his copy if you want.
I think I might have left it on the plane.
Yeah, anyone thinking, oh, another nice romp with monks, but this time it's going to have platypi in it. Yeah, sorry. The platypus in that's actually interesting, and it comes back to the question you asked. Because the point of the platypus is, when platypi got to Europe, people thought they were fake, this whole idea of a sign being a lie. What they thought had happened was that basically cunning merchants, probably in Hong Kong, Cathay as it was then, had got bits of a duck and an otter and a cat and had cunningly sewed them together and sold them to the gullible Europeans. Okay, which sounds like a joke, except for the fact that there were in fact a lot of clever people in Cathay doing just that, chopping up bits of animals, sewing them together, selling them to gullible Europeans. And these things were eventually removed from museums, except of course in the case of the platypus, where they found out that, well, in fact, there is a platypus, and we really don't know, well, it's a monotreme, and we really don't know at that stage precisely how to classify it. So they invented, as we do in our object-oriented programming languages, we have a new special class called monotreme that everybody really knows is really just the platypus. We're done. Any other questions after that discussion? Okay. Talked a bit about this already. Well, if objects are signs, they must be able to lie, because we said if something is a sign, it's got to be able to lie. Well, there's a whole lot of things we can do, like in our farm system, well, which object represents which cow? We can get that wrong. In New Zealand, we solve this by putting barcode tags, or probably these days RFID tags, into the cow's ears. You probably do the same here. Switzerland, they do it just by knowing the names of the cows, I understand. Call them and they come, and they have different bell tones. There's probably something there whereby you could have an audio input. You could listen to the cowbell and work out which one it was. But there's a whole lot of other things we can talk about. Your question, presence or absence, is in fact the object there that represents the cow we want, or is, there are too many objects, whatever. How are these things combined? Have we made the correct choice? So an object is not a faithful model for all purposes. The question is an object going to be a faithful model for our purpose? Or have we got caught out, are our computer systems telling us a lie? Because at some level, if you're beginning to buy this line about these things being semiotic, then, well, gee, I did say the definition of semiosis was that which is possible to lie. You could say I'm saying, well, of course, all of this stuff is just, all our programs are built on lies, which in some ways maybe I'd be inclined to agree on. This isn't really there, right? This side isn't really there unless all kinds of magic make it happen, and we're all willing to believe that what we see actually makes sense. The point here is that objects are not just signs. A slightly stronger claim is they're particular kinds of signs. So in speech, we might call somebody a lion to mean a brave person, or a lamb to mean a docile person. I'm claiming that we're making the same kind of metaphorical substitution when we read our programs, and I'm probably claiming we do that without even noticing it. So we see a bovine object, it's going to refer to some cow, and what we have in our head is this idea that, this object is the cow. This object is the cow. Or the ovine object is the sheep. Yeah?
So isn't this very similar to the problem you were talking about with OO as models, right? Because the question is, what are you modeling? Are you modeling the platonic form of cowness? Are you modeling a specific cow? Only here you say, what is the referent?
Well, yeah, at the level of instances, though. The idea, presuming that our program is set up this way, we will have an instance of the bovine class. That's what I mean by bovine object. Some cow out in the field. The interpretant, the signified, is that, this object, in some sense, represents the cow. We don't think of them as about being separately. The whole point is, and in some sense, that's what I mean when I say programs are built on lies. The lie is that for an awful lot of purposes, an awful lot of really important purposes, we can manipulate this object in our program, and it has the effect of manipulating anything in the world. You take it like that, and I take it like that. The number you get from your automatic telling machine telling you what your bank account is. It's this kind of fabrication, right? The bank doesn't really have that money. The bank is, in some sense, your account, in what sense does your account exist, and in what sense does your account have any money in it? It's a social construct, In that sense, it's a lie, but it's in a lie that we all better agree is the truth, or else we're not going to be able to do anything. Okay? So I guess I'm doing the same kind of move here and saying object-oriented programming has found that I'm doing things this way. So the catch is, well, this doesn't actually work for a lot of designs. This is state out of the Gang of Four book. And the idea here is we want to have objects change their state, so we stick an auxiliary state object in here. This is some kind of abstract class or interface, and we slam particular concrete states in there as things change their state. Yep. I mean, often this is used for networking, so this object will be a network connection object, and the connection is quiescent, the connection is opening, the connection is active, the connection is waiting for a timeout, the connection is closed. Okay? Reasonably straightforward. Okay, so what is this object in this kind of scheme? What is that object in that kind of scheme? Well, my answer is it's still a sign, but it's a different kind of sign. In particular, it's one of these indexical signs, or it's metonymy. These are signs that we've seen before, like the head of the cow or the milk to represent a cow, are based on contiguity of cause, effect, or attribute rather than simple likeness. So the classic for anyone from the Commonwealth or the old empire, we often use the crown to represent a person, and the person we mean, of course, is Her Majesty the Queen. So my argument is that objects can be indexical signs, can be metonymies too.
Give me that one sec.
Sure.
Why is she not the referent?
Well, in this case, the referent is the person, so the referent would be Elizabeth Windsor.
I'm not sure I get that.
That is a good question. The person. What I'm saying is the person is the. Well, in some sense, she is the referent. She's the person.
The physical. You couldn't quite squeeze the actual queen into the slide. Is that sort of what you're saying? So in fact, reference is itself a sign for.
What I'm probably trying to say is when we use the word crown in reference to a person, so the person in that sense is the referent, then what we mean, the interpretant, what I'm hoping to communicate to you is this person that I'm talking about is in fact queen.
Okay.
Okay? In fact, in New Zealand law it works, the American version of this, which is a metonymy that's just the other way around, is the people. As in, not we the people, but as in, the people versus Board of Education, or whatever. So people in that sense is used very similar to this. The word people is used with reference to a litigant in a court case, and the interpreter it's the state. Or, the United States here, isn't it, the people.
So what's important there is that the queen, as the signified, has the power you would expect of a queen, not just as a biological person.
Yes. The point of this is that if I say crown and I'm using it indexically, I mean a crown, it's something you...
Yes, of course.
Here I'm not using it indexically, I'm using it metaphorically. In this case, that is working... Well, technically I'm using it metonymically because I'm using the part to stand for the whole.
Right, but so if you were using crown to represent a treasure, it would be something else. It would be some historical thing in a museum.
Yeah, well, that would be a different sign.
Yeah.
Probably that would also be the same kind of sign, indexical, because probably the idea is the treasure is more than just a crown.
Yes.
So once again, that's a case of exchanging a whole for a part or a part for a whole. Yeah.
So then, is the signified really what the effect that all this has on your brain?
Yes.
Okay.
So Peirce would say the proper significate effect of a sign, which is why I generally don't quote him very much. And he then points out, in reference to your question, that this is then a sign in your head, and you can then carry on with further of these abductive semiotic steps, making further leaps. So, you think of a crown, a person meaning the Queen, and then maybe you, I don't know, think about Charles, and then Diana, and then Camilla, and the whole mess.
Right. But it takes extra work to interpret this slide because you have a photograph that's representing that is assigned to the signified.
Yeah.
That is another confusion. Because my first thought was, oh, you mean person in flesh and blood because the picture looked like flesh and blood.
Right,
But it's not really the fact that it's flesh and blood, it's really the fact that there's all the associations with royalty.
Yes, that's right.
The picture is a sign for a sign.
That's right.
In particular, that there's a crown. There's a crown in the picture.
Deciding over, doing some crownly duty, then it would be easier to...
Okay.
Would the distinction between signified and referent square with Frege's distinction of sense and reference?
It's related, yeah. Yeah. So one of the nice things about semiotics is all the founders all have their own terms for slightly different things. And of course, being semiotic, you can't in some sense, I'm cheating, and I'm mix and matching things here more than I probably should. It's related, I'll say that much. But Frege probably uses those in slightly different ways than the ways that a particular semiotician might use them, particularly in the way that Peirce might use them, and the underlying ontologies will probably be quite different. So, my claim, such as it is that these kind of things operate in our programs in the same way that these metonymic expressions do in language. So, the sheep state object isn't supposed to represent a particular object. If you had an object of a sheep which switched from lamb to a hogget to mutton or something like that, and you flip the sheep state object around, it's supposed to represent the state of some other object in the program. Duh. Sheep iterator represents iteration. It represents a notion of an iteration cursor. It represents some part of another collection of an object. We're not saying it represents something on its own. What about the classic pattern? If you're going to talk about gang of four design patterns, you have to talk about composite. How do you represent these kind of trees? Well, you have this famous structure which, having taught this several times, is counterintuitive in the sense that nobody I've managed to teach to has been able to work this out without someone having shown them first. I argue this is metonymy too. In fact, this is synecdoche, which is to say, related to the figure of speech, where you do talk about exchange the whole for parts. So I might say I'm going to Redmond, meaning I'm coming here. I'm exchanging the whole suburb for Microsoft Research. Equivalent, I might go and say, well, I'm going to visit my Uncle Bill, whom I've never met, but represents, of course, Bill Gates standing in for the whole of Microsoft in precisely this move. It's one of the most common figures of speech, in the same way I claim that composite is one of the most common, well, in the same way that composite is one of the most common design patterns and is doing something similar. It precisely lets you treat an entire structure as if it was just one thing. There are other kind of patterns. They're about programming rather than modeling the world. A classic one is Facade, which says, oh, look, you've got a subsection full of crud, and let's just define an interface and wrap it around the subsystem, and everybody talks to the interface. These kind of patterns seem to be primarily about programming. So the interesting thing we get when I looked at, say, the entire design patterns look is that most of the patterns, though, seem to be these kind of metonymic patterns. They weren't constructing the kind of relationships I said object-oriented design does. The iconic, straightforward ones, we have some object and model something. Rather, what we see the patterns doing is saying, okay, we've got wholes, we've got parts, we've got these other things, and that's what we're using to model. Yeah?
Isn't the reason for that because you weren't looking at a particular object-oriented program, but you were looking at patterns which are kind of meta-programming by nature? So you would expect them to be kind of indexical for that reason.
I think that's part of it. And the other thing, I think, is precisely because the overall rhetoric of object-oriented design is so strongly what I'm calling iconic. In other words, we have this one story that we tell and we teach about object-oriented design, which is you take the world and model them. There's a whole lot of stuff where that's not appropriate. The common cases of that is what ended up in the book. That's my hypothesis, or one of them anyway. So that's the story so far. I've basically said that objects are signs, naive OO modeling is iconic. Where you find you need to do other kinds of modeling, that's what's given rise, or I claim has given rise to some of the patterns. Okay, but what actually are patterns then? Because a lot of this has been about objects. Well, the argument basically is patterns. I presume most of us know what design patterns are? Yeah? Good, so I'll skip that slide. Patterns are stereotypical OO designs, but there's a whole lot of questions about them. Every time I teach a patterns course or a second-year programming course, I always get this one. What's the difference between straight and strategy? I was teaching a class and, talked about patterns. This is the first question I always get. But there's a whole lot of other issues. How many problems does a pattern solve? How many problems does the Goff's proxy solve? Vast numbers. How many implementations should a pattern have? Well, if a pattern is a solution to a problem in a context, only one, but Adapter in the Gang of Four books got about 4. And then there's this big question of, well, what's the ontological status? What, in some sense, are design patterns? Gamma's book focuses on abstract solutions. Alexander talks about languages and liveness and the way and the gait and the quality without a name. It's very nicely written, but I'm not entirely convinced of it as a foundation on which we should entirely invest a lot of effort. Other people talk about group theory. Copeland's done work which argues that patterns form a particular kind of commuting group. There are formal models of patterns. Tommy Mikkonen and various other people are encoding these things up in specification languages. Paulo Borba. People are building case tools. Gregor Kixalis has said, well, a pattern is really just an aspect, That's what he says about everything. So, and the big question is, well, how can you find the right pattern to use? And I must say here, Alexander's certainly got a clue on that. How can you find the right pattern to use? Because once you get more, even with the 23 patterns we've got, or with the vast numbers of patterns out there, this in some ways is really the key question. So, given the talk is called Patterns as Signs, what of course I'm going to say is the pattern is a sign. Something like that scribbled, badly scanned in a notebook. It's obviously something you can read. It's going to be a signifier. The intent is a signified. For those of you who are good with patterns, you probably looked at that, made sense of my handwriting and said, it's the composite pattern. And then one step later, you had all this. Once you know it's a composite pattern, you know that if you can read it, quote, it's going to implement a single quote or tree of quotes that can be accessed uniformly via the quote interface. Whenever the client code expects a quote, you can do all this stuff, right down to the fact that, it was used in interviews and E++ and Smalltalk, because that's where all the design patterns come from, interviews, E++ and Smalltalk. So the intent is a signified, and so the pattern, the solution is a signifier. The design, what we actually put in our program, is the referent. And then this idea, everything the pattern gives us, is the signified of treating the pattern as a sign. Okay? It more or less stops there, except then there's the other important issue about a pattern, which is every pattern has a name. The whole point, or one of the important points about having composite or iterator or proxy is I can use those names without having to carry a whiteboard around with me on which I can draw the diagrams. So we have this, in this case, a two-level metalinguistic semiotic system where at the top level there is this pattern, the actual description of the pattern, but when we talk about it, we can actually use the name and have a sign down here, whereas we basically have a name, composite, all the rest of this stuff is being referred to give the overall sign that here is the pattern called composite that I can just use by saying composite. Okay? Yeah.
I can't think of any human artifact that isn't a sign. I mean, all writing, all art, every creation is a sign in the sense that evokes something, refers to something. So I could have predicted, I think, the title of your talk, Patterns are Signs.
Yes, yes, that's certainly fair enough. ACO did go out, I mean, to basically say, there's a whole world of signs, everything from, the communication of bees to extraterrestrial whatever. One approach to say that the term I like is almost there's a doctrine of signs. So the point you're focusing on is the sign is, if you like, an analytical frame. So I'm saying, given that I'm going to look at things as signs, which only works for certain things, given that I'm looking at things as signs, where does that take me? What can I get from that? I mean, we can think of the table as a sign. I don't know what it's a sign of, but I mean, what would it be a sign of? That's not going to tell me anything about the physical properties of the table, the material properties of the table, how good it is to put, a cup of coffee on or something. It might, for example, be as a sign that, is used to communicate something else. So, believe it or not, on the plane yesterday when I was getting this computer out, somebody in the next row said, "That's a nice computer. Gee, you must be someone of stylish cut and, you must appreciate good design." That's what he said. In that case, the computer is obviously standing as a sign, probably in reference to me, and he's interpreting certain things about, my attitudes to life, universe, and everything. So everything can be taken as a sign, but that doesn't mean that's the only way, the only use we have for things. Okay? I mean, Coca-Cola is wonderful. This is only Coca-Cola because there's the logo on the can. If I told you, in fact, I don't actually drink Coca-Cola, but for the purposes of this talk, Ruston will confirm this. Semiotics being the study of the lie. I actually got a can of Pepsi, poured the Coca-Cola down the sink, poured the Pepsi into the can. Can anyone tell the difference? In just the same way as though you can't see it, because I'm at Microsoft Research, I'm actually running virtual PC on this thing, which I bought to develop Xbox games on, and that's what I'm using to project the slides. So, yes, everything can be taken semiotically. That doesn't mean that the semiotics, for example, completely describe the design and everything about PowerPoint. But there is a semiotic aspect to it. And for patterns, given that primarily what they're about is about communicating about programming, I think looking at that is useful. And I know people have to go. So I'll just give some examples of that, and then we're pretty much done. What's the difference between state and strategy? Well, the diagram is a little bit different, but in practice, the way that you're supposed to read these diagrams basically says you abstract away from all the particular names. The diagrams are the same. That's why people ask the question. The answer is, if you think about these things in those diagrams, you can say, well, yes, there is a common design. There is a common design. But the intent that you get and the rest of the pattern is completely different. In other words, they're there for doing different things. Okay, and the difference between state and strategy is not in the design that's shown on this slide. It's basically in everything else that's in that pattern apart from the fact of these two diagrams. And the reason people ask this question is because the way the Gang of Four book is organized, that state and strategy are after each other in alphabetical order in the same section of the book. And in fact, there are other patterns, like the book then goes on to say, actually, strategy as a pattern is in fact much closer to something like decorator than it is to state. In many problems you're solving, the real question is not between state and strategy, which rarely arises, but between, say, state and decorator. But because of the way the book is presented, that kind of commonality just isn't brought out. Well, in fact, in spite of the fact, I should say, there's actually a section explicitly discussing it in the book, which isn't called a pattern, so nobody reads it. The patterns have different intents. Meaning comes from the difference, asking where does a strategy start and where does state begin. If you've got this idea that meaning is generated by things pushing against each other, then the answer is, well, there's not going to be a firm boundary there. There are going to be some things that are more clearly states and some things that are more clearly strategies. Same way, well, an adapter has 4 different solutions. In this case, probably each solution, it turns out, if you look at adapter, actually has a different intent. They adapt different things. All that's really going on here is we're using the same name for things that at some level are really different patterns. Okay? This might all sound obvious, but within the patterns community, vast amounts of heat and light have been generated over precisely these kind of things. Nasty letters have been sent to people's publishers saying, yes, well, you really shouldn't have a pattern called foo object in your book because I've got it. And it's not entirely clear to me that this thing is well served by going that way. Once we have an idea that there are multiple levels of things going on here, and that even if you look at the design patterns book, it's like, well, there are different kind of adapters. They're all doing basically the same thing. Misinterpreting patterns, well, if patterns lie, if patterns are signs, they can be used to lie. Can this be used to lie? Well, who knows what this diagram is? I said it was composite, but you chose or chose not to believe me. This could be the proxy pattern because this thing isn't an accurate, it's just a sludge. It could just be a mess. It could be a diagram that was left on the board from last week that I just happened to copy. It could just be a mistake. It could be devious because, in fact, what's going on, as occasionally happens in our labs, one group of students is worried that another group of students is copying their design, so the first group of students draws up a very elaborate design that is wrong or flawed, or at least that they think is wrong or flawed, on the board and go away and leave it for the other students to notice. Maybe that's what's going on here. We don't know. In that sense, patterns can be misinterpreted, and that is in some sense saying, well, here's a reason why to consider these things as signs. Patterns can be in their written form also as expressed in programs. This is basically what I've just talked about.
Go back to that one.
Yeah.
Okay. I do have a question. I'm really curious, but might be out of context. How does the theory of the lie get resolved when you start in error handling?
In error handling?
Yeah, so okay, when a program is running, that to me would be a result of a lie or a program. Is there an analogy or a connection here? Do you see one in this area?
Do I see one?
I've been trying to understand the theory of the lie and then take it down to a program.
I suppose, in some sense, the most obvious, I can't see something straight on the top of my head. There's a slide later on where, as computer scientists, we're trained to believe we're dealing with specifications. We're trained to believe that a specification has an implementation that implements it correctly. Mm-hmm. We're trained to believe that our models describe what's going on in the real world.
Right.
I would claim, without any evidence, that taking a semiotic approach may in some sense make us a little more humble with respect to all those things, so that we are less surprised when implementations don't meet the specification, which could be for a number of reasons, due to the specification being misunderstood, or similarly when our programs, or the reality as modeled in our programs, doesn't correspond to what the users of our programs expect them to do or think is real. So I don't know if that's an answer, but it's a fairly big question.
So applying it back to one of your early examples, is this like the library where I model a book as either being checked in or checked out, and in fact then the first stolen book shows up and I'm hosed because my model is inherently a lie.
Right. The classic cases, and when I was teaching use cases 2 or 3 weeks ago, we do Larry Constantine's extensional use cases. The question is, what's the use case for checking in a book? What's the use case for checking out a book? Do you have a precondition in there that says this book is not checked out? Most students do, because that's, computer science preconditions. We're checking out a book. Obviously, it's not already checked out. Except this happens all the time at libraries that, somebody walks in and says to their mate, oh, have you finished with that? I'll have it. Doesn't take it to the checkout desk or to the check-in desk, the returns desk, takes it straight to the checkout. Okay? What's happened is, at some point that book, in the mind at least of the users of the system, has gone from being checked in, gone from being checked out to being returned without any way of telling the system. And so the book turns up at the checkout and you want to scan it. And what all library system designers do, and they know this, is they say, oh, fine. Well, fine. And we just change it checked out to and off we go. And that's almost certainly the right way to handle that. In fact, you actually want to do some of the check-in checks, because if there is a request outstanding for the book or something, you need to process those. That's actually part of the standard checkout process anyway. So The question, I think, in design patterns is the pattern selection problem. Which pattern should you choose? Now, I think Alexander has probably the best pattern here, which is we have a pattern language, which is a rooted directed graph of patterns. You start at the initial pattern in the language, and you work your way down, and you know everything. So in his book, the first pattern is called independent regions, and the problem Alexander's book starts out with is how do you organize the world, and then carries on right down to how you should carve designs into the walls of the mud brick houses that you've built if you follow his pattern language. Okay? So I suppose what I'm saying is I think that is, you know, and in theory you can get from one to the other by starting at the top and following all these directed links. And the directed links are of a particular kind. If you are doing this pattern, then you should go on and do the next one. The catch is that we do not seem to have any substantial pattern languages for software design, at least not on the basis at which those things, you know, like Alexander's book, amongst people who actually build buildings, serious practicing architects. None of them regard Alexander's book, or very few of them regard Alexander's book in any way seriously. And even the ones that do, don't regard it, don't apply it anywhere near as closely as we might imagine that people would in the software patterns world. In software patterns, what we have got, and I've got very good at, is collections of individual patterns, which the Gang of Four book is one. Kent Beck's Smalltalk Best Practice Patterns is another. And there's a whole lot of these things out there, or individual patterns. I could talk about, you know, the null object pattern, which would probably fit quite nicely in the Gang of Four book, but, you know, wasn't included. They didn't think of it at the time, etc., etc. This is what we're good at. This is what we've had success at. And I would argue in terms of impact on practice, the software patterns have been much more effective than Alexander's patterns were in the domain of architecture. Now, the question of whether he really expected them to be used or whether they were intended to be used in that way is beside the point. And I'm not saying I don't like Alexander's work, but I'm saying the software patterns people have had real results, and they had real results with these collections of catalogs. Patterns collected together, in some sense presented in some kind of random order, but if you look at something like the Gang of Four book, you'll see there's actually a whole lot of relationships between the patterns, some of which are brought out in the body of the patterns. The interpreter pattern is explicitly described as, well, first you build a composite and then you do this other stuff. Or other relationships that in some cases are described in other sections in the book. So my argument is, if you look back at what semiotics and what some of the linguistics people hypothesize about the way that we organize knowledge about signs or about language, they say, well, we don't think of this in terms of a dictionary, but in terms of an encyclopedia. In other words, we have the patterns and then many relationships. So obviously this composition relationship which says, you know, if you are building a composite, if you find yourself in this thing, if you've applied this pattern, then go off and apply the next one, is really important. That's what Alexander's catalog uses. But semiotics says there are others as well, some of which we've talked about. So, you know, this relationship of alternative patterns. This relationship, there could be two patterns that have a similar design but have a different intent. If we expect people to use our books of patterns when they're reading through code, it's actually quite important that they can see the design that should be state and strategy and have some way of getting to the fact that, well, this could be state or this could be strategy, and have some way to get to either of those things. Alternatives, specializations. There are other relationships between patterns that just doing Alexander's structure, it seems to me, doesn't capture. The important things you look at is this idea, if you say an encyclopedia, what we're interested in doing is evolving a common vocabulary. Like I said before, the null object pattern and perhaps a couple of others are well enough used in the OO design community that you should think, well, why wouldn't they be in the next edition of the Gang of Four book, were the next edition of the Gang of Four book to be produced? And I know that various textbook authors have done this by sliding a few of their own patterns in. The nice thing here is that with this idea of an encyclopedia, of a graph of patterns linked by variety of relationships, you can add and remove patterns without affecting the integrity of the thing you've got, in some sense like a wiki web. The catch with Alexander's pattern language is because it's formally a rooted directed graph. In practice, if you're managing large collections of patterns, or even medium-sized collections of patterns, it's much harder to do that, if you're concerned about this entire structure, the structure often seems to come to dominate the information that you're putting in particular patterns. So individual patterns or small groups of patterns linked with relationships seems to me to be a more effective way of progressing things than saying, well, we should sit back and try and build this kind of large structure. So to finish up, what kind of stuff have I said? Boom. Inasmuch as programming analysis, design, etc. are things to be interpreted, this is the point I made before in response to the question, then they're susceptible to semiotic analysis. I'm not saying that this is the only kind of analysis. There's a whole bunch of stuff there. Think questions of genre, for example. Literature, you might talk about, a movie is a particular genre. Is it a Western or is it science fiction? In the same way, maybe this idea of programming paradigms is a similar thing. Other uses of semiotics, obviously in UI design, that's created with interpretation, explaining programs, understanding what we do when we look at programs, what kind of information we need might be susceptible here. I'm actually going to skip this because I think we're out of time, but if you want to know where pro wrestling comes in, you can ask me later. Metaphors often used to explain programs, not the world. Well, that's fairly basic in our programs. We can have a trash can object used to explain some kind of object or deletion function. I've already said, I think you can think of things like a stack. We use that to explain the object in the system. And this relationship of implementation can be thought of as semiotically, and I've said this before, so the stack object is in some way acts as a sign where the representment is the actual details of all the objects that cooperate to implement the stack. So what's the point? Well, in some sense, the point of this work and what motivated me on it was trying to answer this first question that I mentioned that everybody who I've taught patterns to seem to ask, which is, what's the difference between state and strategy? The answer is, well, it's the intent of the pattern. And to do that means we have some kind of split between the design and between what the design is trying to do or the features we want or how balance of the forces. Design patterns versus object-oriented designs. OO designs are metaphorical. That's the way it's taught. That's not a surprise. You shouldn't also be surprised that most of the patterns we produce actually produce objects that relate to what they claim to model in different ways, in extended ways than the standard OO story. Once again, that shouldn't be a surprise. Both patterns and OO design, well, for the purpose of this talk, both of them can be seen as signs. What I'm trying to do is bring this work in semiotics, which is not from within computer science, and saying, does it provide any useful explanatory value for what we do when we talk about patterns and designs? And I think using that I can construct answers to open questions. Yeah.
So when you say most of the patterns are metonymy,
yeah,
you wouldn't say that if they had patterns like customer or invoice or something like that, because that would be metaphorical.
Right. Right.
And because they felt those were obvious, instead went to the less obvious.
Yeah, that's basically what I think. That's what I think. That doesn't necessarily mean that they shouldn't have. And if I looked at analysis patterns, for example, maybe I would have found different things. It's something I haven't had the time to do.
Okay, so to some extent, I came to this talk because I had already kind of bought off on the theory that patterns are signs. If we look at patterns as semiotic structures, what can I learn about what makes a good pattern or a bad pattern as a sign? So in what ways are some patterns maybe good patterns technically, but they're bad because they're bad signs?
The first thing I'd want to say, which may get me branded as a relativist, is, why do you call me good? So the first question is, good for what purpose? This isn't new in the patterns community. The first rule of patterns is, the first question you get asked if you submit something to a patterns conference and you haven't said is, well, who's the intended reader? So the first idea about patterns of signs is simply it's not simply about, what would be on the left, the pattern text we write. It's not simply about what would be on the right, the design. Okay, the point of this. It's not even simply about what goes in your head when you use it. It's about the totality of the whole thing. Okay. In other words, the pattern community has been particularly good when we look at patterns of expression of saying, well, what about the fonts? But if a pattern is assigned, we have to consider the referent, which in this case is the design that's going to be produced, as well as the fonts. We've got to think about how that's all going to work together to produce an effect in the mind of the person who reads it, and whether that is the effect that we want to produce. So I'd start there and then carry on. That's a short answer, but I can certainly talk more later. Other comments or questions?
I suggest we stop here, and if we have further questions, let's take them offline.
Great. Thank you very much.
Let's start talking about patterns
Yeah, so the notion, after listening to this, it seems to me the goal of a sign is to generate a concept. It's essentially, it's a stimulus whose goal is to generate a concept in the viewer.
Yeah.
And so what is the signified is really the concept you're attempting to stimulate.
Yeah, well, that's where it starts getting fun, because there's this issue.
Spend some time with David talking about
There's this issue of, okay, the intended sign versus the sign that actually gets produced, if that makes sense.
We do now. I just have one question. So, I'm getting back to your signs and all that stuff, so a lot of this is really
Okay.
I only have one question. So how would you define information in the sense that everything is a sign? Definition for open and closed system. But I don't think everything is.
You do or you don't?
Yes, both. That's my specialty, is learning and understanding, how a girl needs to deal with ontology. And everybody knows problems with.
Yeah.
The scenario describes a situation that signs and stuff like that. I didn't mean to.
Yeah, I agree. I'm tempted to start whimpering and hide under the table.
Whereas what he's saying is, this is loaded. I've been doing this for 15 years.
I kind of picked that up.
But I'm fascinating because I never really. I'm always going to draw the picture. And I have that sense of the sign, it's a sign for the solution, whereas the scenario is a sign for the problem. We might work after we.
Something I've seen people say is that data is, the bits, the representation. And so the information is the interpretant or the signifier. So you could say there's the map. You could say the difference between data and information is signifier and signifier.
In any given scenario, there is a set of This is one. It wasn't.
I'll blame it on jet lag, but it's not really.
I know. A well-formed scenario, carefully drawn scenario. It's informative. Carefully drawn scenario is not valuable because you can't say much about it. Answer the sign. Virtual machines. And you have a probability of everyone to answer.
Yeah.
Information is a receipt of energy that changes the probability of the answers.
Yep.
And as bits of the chance and there's no communication happens. I've been working hard on patterns. And then we'll get more from the mathematical way. This might be.
No, it's not. And I mean, you then get into the issue of irreducible with, non-redundancy and stuff.
Right. You go straight down to girl.
Right. But
in fact, that's my thesis. Girls theorem, where I inverse the theorem myself.
These are so well. These.
So I've been minding my lesson for anybody.
Formatting stuff, but then.
okay. So the short answer is Particularly Eco in his theory of semiotics has, I mean, I know it's there, I haven't looked at it, because at this stage I haven't been looking at it. I mean, in general, this is a liberal arts humanities approach, and we're not interested in, the aim is not to quantify things. So, if I really wanted to play the game, I'd say, well, that's all very nice within your Aristotelian closed framework, but we're not there. And so I'd say patterns aren't there either, and we don't have things like mathematical models of readers that are particularly good. And in order to theoretically evaluate how well a pattern works, you'd need all that kind of stuff. And you're better off taking an HCI approach and in fact doing what the patterns community does, which is engage in the workshopping and the negotiation process that happens there.
Well, the big thing I go back to modeling people, this is what I learned before, that was back about, is that the big thing about patterns is they're empirically derived, they're not algorithmically derived. So, because, this is what's interesting about the signage is that people's problems, that they see coding when they code it. So it's more of a biological derived empirical knowledge when they find patterns. This is after watching all these workshops for the last 2 years and reading about 900 patterns over the last, is that they're empirical, because when you start talking about the language, you start looking at together.
Patterns, I mean, I'm going to come back and say, patterns, especially when you're talking about patterns, you're going to say they're repeated structures in some kind of representation, which, carry some signification. So it's certainly possible to identify those repeated structures, all right, mathematically. Just by getting a whole lot of stuff and analyzing. I mean, in some sense, that's what I did at the start of the talk with those Nord programs. I found out stuff about the programs I didn't already know just by getting a whole lot of them and analyzing them. And then the Scandinavian linguists talk about a commutation test, which is when you've identified the structures, you then permute or deform the structures